Hi guys, am I audible? Am I audible, guys? Respond to the chat box if I'm audible. Morning, guys. Is my voice clear? Happy Diwali. Awesome. So we are going to start with a mini quiz of some solid questions in geometry and mensuration. So the quiz can be parallelly taken at georgeprep.com/dashboard. Please visit there and you should be able to see a live quiz that is there named Geometry YouTube session. So the pattern is going to be, we're going to attempt a question and come back here and discuss, come back here and discuss. And we will also have a live leaderboard going, so we'll know how you guys are performing as well. Okay. So I'm going to start the quiz. Please refresh your page once to get the latest version of the quiz. If you're already at georgeprep.com/dashboard to take the quiz. Great. I'm starting the quiz right now. You should be able to see the first question flashing there. And I've activated the first question here as well. Don't worry about the initial timing that it is showing here. You have 3 minutes for this question. You'll have slightly greater time for the first question in case you haven't started yet. For the first question alone, the timer is running here. Okay, the time is up. So let's discuss this one. Before that, let's see what is the standing of the leaderboard. Awesome. So we have Swati on the top right now. Only 2 of them have been able to solve this within the time. Let's see how to approach this question. In case some have not solved yet, I'll give you probably another 30 seconds. In case you joined the session later, please attempt it if you haven't attempted yet. Because I could see only 2 have solved it. Okay, I think we can discuss now. Let's look at the question as to what they're asking for. In the given figure, a rectangle ABCD is inscribed in a circle. Just 1 minute, guys. There's a bit of a problem here. Okay, you're back. Okay, let's look at this. In the given figure, a rectangle ABCD is inscribed in a circle. The length AB of rectangle is 24, breadth is 18. Okay, length and breadth are given. Find the area of the shaded region given sine 36 is 0.6. That itself should give me some kind of clue that somewhere it's going to get involved. And pi is to be taken as 3.14 for this question. Okay, so let's first put down whatever is given. So they have given that length of AB is, the length AB of rectangle is 24. So this has to be equal to 24. Let's fix that. So this is 24 units and the breadth is 18. So AD should be equal to 18 units. Shaded region they're asking for. Okay, how do I find the shaded region? I can find out the rectangle area. That's going to be damn simple. Now, if I can also find out the 2 segments that are there to the left and right and add them up to the rectangle, I should be able to get the answer. So the required answer is going to be area of rectangle ABCD plus area of the 2 segments. So I can probably put 2 times area of the segments. Each segment is going to have same area. So area of rectangle ABCD plus 2 times area of the segment. If I do, I should be able to get the answer. Okay, area of rectangle ABCD is not going to be a big deal because we have got both. So 18 into 24, that should give us the value of area of rectangle ABCD. Now 2 times area of the segment. To find out area of the segment formula goes like this. R square into pi theta by 360 minus sine theta by 2. So that is area of segment formula. I'll have to multiply that by 2 because I have got 2 such segments, right? So that should be our target now. So let's put 2 into here itself, lest we might forget. Okay. So now what I should get? I should be able to get this theta, right? If I can get the theta, now R value we can get because I've got 18 and 24 here, and we are dealing with a rectangle, which means the internal angles are going to be 90 degrees. So this is going to be 90 degrees. Just give me a minute, guys. Okay, so this is going to be 90 degrees. So 18 and 24 we have. I can take the hypotenuse by using Pythagoras theorem. Or if you know the triplets, this 18, I can think of it as 3 into 6. This is 4 into 6. So my diagonal has to be 5 into 6. So diagonal overall is going to be 30 units. I'll just put it here in case you did not get what I was saying as I was quickly saying it. 3 into 6, this is 4 into 6. So 3, 4, 5 is our triplet. So my diagonal is going to be 5 into 6. So it's going to be 30. So if diagonal is going to be 30, then each of these parts is going to be 15 and 15, because in a rectangle, the diagonals will bisect. So I'm going to have 15 and 15, which means radius they have got. Radius is going to be 15. Now I'll have to get this theta. If I can get the theta, the question is over. Right. So let's see how we can get the theta value here. Now to get this theta value, I can draw a line like this, which is going to be perpendicular to the side. So let's draw a line. From here, I could draw a line like this. Okay. Such that it is perpendicular to AD. So now this line will give us a right angle triangle to deal with. This is going to be 90. And this line will also bisect the side, right? Because we are dealing with an isosceles triangle here where I am putting this perpendicular. So as the whole thing is 18, this is going to be 9 and 9. Okay. So if this is 9, this is 15. I am trying to find out this angle theta, right? So sine theta is opposite by hypotenuse, right? So sine theta in this case, opposite is 9, hypotenuse is 15. So that's going to be 9 by 15, right? Which is 3 by 5, which in turn is 0.6. And it is given here sine 36 degrees is 0.6. So I can conclude that my theta is going to be 36 degrees. So let me put it here. Theta value we can conclude is 36 degrees. So once I conclude theta is 36 degrees, then I can conclude this angle DOA is going to be double of 36 degrees, which is going to be 72 degrees. Means we got this theta here. Okay. Now this theta is not the theta I've written here. That is DOA, because for this segment I'll have to take DOA as the angle. So this theta in this expression is going to be 72, which is double of what I have taken here. Let me just put as theta 1 just to get rid of any confusion. Okay. Theta will be double of theta 1. Okay. So now we've got all the values that are required. We just have to go ahead with the calculation and solve this question. So let's do it. So this is going to be 18 into 24 plus 2 times of r square. R is 15, radius. 15 square into pi. They have asked us to take it as 3.14. So 3.14 into theta by 360. Theta is this full angle DOA. Angle DOA is 2 times of our theta 1, which we have found here, which is going to be 72 degrees. So theta by 360 will become 72 by 360, which is exactly 1/5, right? 5 times of 72 is 360. So I can say this by 5 into sine theta by 2. So sine of 72 by 2. Now the thing is, we don't have sine of 72 here. Okay. So now if I have to go through a different formula, let's say, okay, this is not working for me. I want to go through a different formula. Then what we can do is, if I don't want to deal with this sine of 72 in this case, then we can go with a slightly different formula. What is the other formula that I can use to solve the same question? There is one more formula I can use if sine of 72 is not known at this stage. One more way of approaching the same question, instead of going with area of rectangle ABCD plus 2 times of area of the segments, is I can just take 2 times the sector here, because in that case I just have to go for theta by 360. I can go for 2 times of the sector area, and I can add up these two triangle area if sine 72 is not known. Okay, so if you know sine 72, you can go ahead and solve and get this. So the alternate way, if sine 72 value is not known, could go like this. What I'm going to do is, I'm going to take area of these two sectors, DOA, this full sector. Segment will only mean this area, sector will mean the whole thing. Okay, so the alternate way, if sine 72 value is not known, is 2 times of area of sector plus this triangle plus this triangle, that is area of triangle DOC plus area of triangle AOB. 2 times, they both are going to be of equal area. They are congruent triangles here, so they both are going to have equal area. So 2 times of area of triangle DOC. If I do this, then I will not face a sine 72 situation here. So let's try doing this. So 2 times of area of sector. Area of sector, how do we find out? Theta by 360 into pi r square plus 2 times of area of triangle DOC. Now, area of triangle DOC, now sum of the areas of these two triangles will be equal to the sum of the areas of these two triangles in a rectangle, which means this plus this should be equal to exactly half of rectangle area. So 2 times of DOC plus AOB should be of area of ABC. Now this formula is much easier to deal with because we don't have any sine 72 situation here. So I can go with 2 into theta by 360. Again, theta is 72, so it's 1/5 into 3.14 into r square, that is 15 square, plus half of area of triangle ABCD. ABCD is going to be 24 into 18. It is going to be 24 into 18. Now this is much easier to simplify than trying to deal with the sine 72 value. Okay, so this is going to be what? 2 by 5. Now you can use your calculator, assuming that you are trying this in CAT. Plus this will become 12 into 18. Okay, let's put that in a calculator and see what we will get. Anyway, we are getting some decimal values here. So doing it without a calculator might take definitely a little longer. At least this part we should put in a calculator. Let's try doing that. Okay, this is a minus. This part is a minus. Can you put this in a calculator and tell me what answer you are getting? If you put this in a calculator, you will get 498.6 as the answer for this question. This part you'll have to do. This we can do. 12 into 18 you can do. That is 12 into 9 is 108. 108 into 2, 216. So this part is 2 and 6. This might require putting that in a calculator to get the, this is 0.4 into this, or if you really have time, you can solve it in your hand also. 0.4 into 3.14 into 225. You solve that, you'll get 498.6 as the answer for this. Yes, all calculators generally follow BODMAS. Okay, they will follow BODMAS. So this is coming to how much? 282.6. Someone is telling. I don't have a calculator with me right now, but you can do that in a calculator. You will get the answer as 498.6 as the answer. Okay, someone is asking, how is DOC plus AOB equal to half the area of ABCD. Okay, let's try to figure out that part. Why is DOC plus AOB half the area of ABCD? Okay, if I take DBC, I'm going to prove why the triangles are going to have equal area. That will establish why two such triangles should be giving me half the area of the entire this one. So if I take DBC, now DBC will have exactly half the area of the rectangle. That's very clear, right? Because I have two congruent triangles, DBC and DBA are congruent triangles, SSS congruency. So DBC and DBA will have equal area. Now what I'm trying to do is find out the relation between DOC and COB. Now in a rectangle, these two sides are going to be equal. This side and this side, that is DO and OB, are going to be equal because diagonals bisect. They bisect in a parallelogram itself. So in a rectangle, they should bisect. So if I take DCB, then DOC and COB should have same area. Why they will have same area? Because the bases are equal and the height is also equal. So DOC and COB will have same area. So let's say that area is A, and this side DOA and AOB will also have same area. So that I can put as B and B, and I can say 2A is equal to 2B, which means A is equal to B. That proves that DOC, COB, BOA and AOB, each of these four triangles should have equal area. But not all four are congruent. You can say these two are congruent and these two are congruent, but area wise they will have equal area, right? So if four of these triangles are going to have equal area and I am considering two such triangles, then I am looking at two out of the four triangles. So they should give me half the area of the rectangle. Is that clear? Those of you who are there in the live session, please type 1 if you're clear with how we approach this question. Great. Let's move to the next question now. I'm going to change the question in the quiz and then I'll come back and change in the slides as well. Okay, the second question is up in the quiz. Visit georgeweb.com/dashboard to take the quiz. And the second question is up here as well on the screen. You have 3 minutes for this. If you know the property, or if you had solved questions like this where you have a circle, a square outside and a square inside, and in between you have a circle, if you've solved questions like that, you can solve this question very easily. up. I'll give you 10 more seconds in case you start a little late. Someone was telling I don't know much quants what to do. Okay, the questions that we're dealing with today are slightly on the advanced side, but I'm going to explain the questions. Don't worry about it. But to be able to solve those questions, you should have solved a good amount of, because the questions that we're dealing with today are the questions which will take you beyond 95 percentile in CAT. Okay, the 95 to 99 kind of percentile, those kind of questions are the questions that we're dealing with today. But I am going to explain, so you should be able to understand. Don't worry about it. Okay, so let's see what is the standing of the leaderboard right now. Oh, Triveni is on top, followed by MSD Ashish, Bhargav, and so on. Great. Now let's try to discuss this question. Okay, ABCD is a rectangle. A circle internally touching all the four sides of ABCD is drawn. Another rectangle PQRS is drawn such that all its vertices are on the circumference of the circle. The area of rectangle ABCD is at least X percentage of the area of the rectangle PQRS. What is the value of? Okay, so we have rectangle, circle inside, and another rectangle. So let me put the circle first. So let's say that's our circle, and there should be a rectangle outside and a rectangle inside as well. So let me change the color for the rectangle. I'll be able to move this. Let me try and move this rectangle. One second. Okay. That's our outer rectangle that they are speaking about, and we will have one more rectangle inside also. It should be something like this. Okay, so this is the situation that we're dealing with. We have a circle, and that circle, let's quickly read this. ABCD is a rectangle, so let me just start marking them as well parallelly. ABCD is a rectangle. Let's say this is A, B, C, and D. A circle internally touching all the four sides ABCD is drawn. Okay, we have the circle, the pink color. Another rectangle PQRS is drawn such that all its vertices are on the circumference of the circle. So the one that I've drawn inside is our PQRS. So let me just put it here. This is P, Q, R, and S. What is the area of rectangle ABCD is at least X percentage of area of rectangle PQRS. So let me put that expression here that they have given. Area of rectangle ABCD by area of rectangle PQRS into 100 is at least some value. So what I should do is I should try and minimize this expression. That's the target, right? We should try and minimize this expression that we have got and see what is the minimum value that the expression will take. So let's see. I have to minimize. Okay, so how do I minimize this? One thing you should notice is when it is given that you have a rectangle inside which you have a circle which touches all the four sides of a rectangle, then the rectangle has to be a square. Okay, if I'm able to put a circle inside a rectangle such that it touches all the four sides, it has to be a square. It can be proved. For instance, I can take like this. Let's say this part is A. Then because of tangency, this part will also be A. That is from here till here and here till here. Both of them will be A and A. Similarly, I can say this will be B. This will be B. this, let's say C, from here till here, let's say it is C, from here till here, if I say it is D, from here till here, it is D. Okay, now we know that A plus B is equal to C plus D, right? A plus B is equal to C plus D. Okay, so now you can start saying that as this is going to be half, exactly half of this, now this will also be equal to C. So this can be proved. That should not be much of a problem. You can prove and say that whenever you put a circle inside a rectangle such that it touches all the sides, then the rectangle that you have outside should be a square. So that is the first inference that we have to draw, that this one, the blue one that we have, is a square. Okay, now if the blue one is a square, then the area of the numerator is fixed. You can take some radius for the circle. Okay, so some radius for the circle. The outer one is a square, so area of this one is fixed. So this is fixed. Now, given the fact that I have fixed this, because the outer one has to be a square and the square should have one particular area only, whatever dimension you take, accordingly all three will change, right? So you can fix some dimension for the outer square, so that will get fixed. Accordingly, the circle will get formed. Accordingly, the internal rectangle will get formed. Now, I'll have to minimize this. Now, if the numerator is getting fixed, and now I'll have to do something with the denominator. So what should I do with the denominator when a fixed numerator is there to minimize the whole expression? Should I maximize the denominator or minimize the denominator? I have already fixed my numerator. The fraction has to be minimized. So what should I do with the denominator? I'll have to maximize the denominator. So the rectangle that I'm going to draw inside should be such that the area of the rectangle should be maximum possible, which again leads us to another square. So inside a circle, if you draw a rectangle such that the area is maximum, then that also has to be a square. We can probably prove it like this, but this is something that you should remember in terms of symmetry. But let's quickly try and see why it will be a square. So let's say the length and breadth of the internal square, the internal rectangle, we're going to prove that it is a square. The internal rectangle, the length and breadth, let's say it is L and B. Okay, now what we are trying to do is, we are trying to prove that this one has to be a square. Now, whatever be the state of this rectangle, the diagonal of this rectangle is not going to change. That is going to be equal to the diameter of the circle. In whatever shape I draw this rectangle, the diagonal of the rectangle is going to be equal to the diameter of the circle. So diagonal of the rectangle is going to be, let me just draw that line here. Okay, so that's a diagonal. That is going to be square root of L square plus B square. That is fixed for a given circle, irrespective of what kind of rectangle you're going to draw inside. Okay, so I can say when L square plus B square is constant, when the diagonal is fixed, I'll have to maximize L into B. I'll have to see for what condition it gets maximized. Right. So you can take Amgm inequality here. If I take Amgm inequality, I can say L plus B by 2 is greater than or equal to square root of LB. Arithmetic mean of L and B should be greater than or equal to geometric mean of L and B. So if I take 2 to the other side, I'll get L plus B greater than or equal to 2 times of root of LB. I can square both. I'll get L square plus B square plus 2LB is greater than or equal to 4LB, which will lead me to L square plus B square is greater than or equal to 2 times of LB. Now, when you're looking at arithmetic mean greater than or equal to geometric mean, that equal to will only happen when the values are equal. Okay, so in this case, if I am going to fix this, if I'm going to take L plus B square as a constant, okay, then 2LB is going to be lesser than or equal to some value. So the maximum it can take is when it is equal to this, and that will only happen when L is equal to B. So that proves that L into B is equal to max when L is equal to B. Okay, now this is not something you'll be doing in the exam. This is a result that you should know, but I'm just trying to prove it so that you'll be able to remember this. Okay. So when L is equal to B, so only when the length and breadth of this rectangle are equal, the rectangle will have maximum area for a given circle. So the inside one is also a square. So we have two squares here. The outside one is a square, the inside one is also a square. Okay, I just want to know whether everybody is clear till here. Type 2 if you're there in the live session. Or the two squares that we have established already, that both of them are going to be a square. Okay, let me clear off a part of this which is not necessary anymore. Now we just have to figure out the ratio of the areas of the outer square and the inner square. Okay, so outer square, if I'm going to take the side of the outer square as, let's say, S. Okay, side of the outer square, if I take as S, that is also going to be the diameter of the circle, right? BC is also the diameter of the circle. Now, diameter of the circle is also the diagonal of the inner square. So I'm just going to take the squares are similar figures. Any two squares you take, they're similar figures. So I'm just going to take side of square ABCD by side of square PQRS. I can square that to get area ratio, because for any two similar figures, you can take the corresponding side ratio, square it to get the area ratio. So let's see this. So side of ABCD I'm taking as S. So let's just strike it down and take S. Now F is also diameter of the circle, which is also diagonal of our internal square. So for square, if diagonal is S, then the side will be S by root 2. Okay. So sides are in the ratio 1 by root 2. So root 2 by 1. If I cancel this, it becomes root 2 by 1. So sides are in the ratio root 2 by 1. So when I square, I will get area in the ratio 2 by 1. So once you get area in the ratio 2 by 1, that is the minimum you can have for this. Okay, because based on that only we established that they both are squares and so on. So 2 by 1, if this is going to be 2 by 1, the question is asking for area of rectangle ABCD is at least X percentage. So that X is going to be 200, because this is going to be at least 200%. So answer is 200 for this question. I hope I am clear. Those who are in the live session, please give me a response. Type 200 if you're clear with why the answer is 200 for this question. Awesome. Let's move to the next question. The third question is up in the live quiz. In case you haven't seen the live quiz yet, visit georgeprep.com/dashboard to attempt the live quiz. And the question is up on the screen as well. The timer is running on the top in case you are looking at the screen and trying to solve. Okay, the time is up. Let's see what is the status of the leaderboard now. We have Triveni on top, followed by Sultan, Sadiq, Sravanti, MSD, Ashish. Great. Let's see how we can solve this question. So first we'll have to construct the figure carefully because they haven't given any figure. They have just described what is happening. So let's construct the figure. PQR is a triangle. A line segment is drawn from vertex P intersecting QR at T. So first let's form the triangle here. Okay, so let this be our PQR. Let me label them so that our future lines are all proper. So let this be P, let this be Q, let this be R. That's our triangle. And what is next? A line segment is drawn from vertex P intersecting QR at T. Line segment is drawn from vertex P intersecting QR at T. Let me just change the color so that these things are all clearly visible. Okay, line segment is drawn from P intersecting QR at T. So from P intersecting QR at T. So that point is going to be T. Another line segment is drawn from Q intersecting PR at S. From Q intersecting PR at S. So probably something like this. I just want to make sure I don't draw it like it is 90 degrees because I might assume it is 90 degrees then. So let me just put it like this. Okay. So another line segment Q intersecting PR at S. So that is going to be S. Okay. Line segments PT and QS intersect at U. So PT and QS, they both are intersecting at U. Root 2 times of PS is equal to QR. Root 2 times of PS is equal to QR. Okay, let me just put it here. Root 2 times of PS is equal to QR. I'll have to remember that when I want to establish this one. Okay, and the length of PU is thrice the length of UT. Length of QT is half the length of TR. Let's put that one. Length of PU is thrice the length of UT. So PU is thrice the length of UT. So I can say if this is 3x, this is going to be just 1x. PU is thrice the length of UT. And length of QT is half the length of TR. QT is half the length of TR. So this is going to be the ratio 1:2. QT is half of TR. So this is going to be 2y. If TR is 16, okay, so this is given as 16. This is 16, then this should be 8. Means this whole thing is going to be 24 because we got this QR thing here. So I can say PS is equal to 24 by root 2. Right? Because we got QR as 24 right now. So this is going to be 24. So this part QPS is 24 by root 2. This is not required anymore. This is going to be 24 by root 2. Okay, what else? Find the measure of angle QRP in degrees. QRP, this angle they are asking. Measure of this angle. Okay, there are at least two ways I can think of to solve this question. One is using mass point geometry. The other one is using normal properties of geometry. So first I will solve it using the regular properties of geometry. Then I will show how you can apply mass point geometry to solve this question. So using regular properties. So this one is 8, 16, any other value we have got. QP is also there as 24. Let's fill that also. I missed that one. QP is 24. So this is also going to be 24. I hope I have taken all the data. TR is 16, QP is 24. Length of QT is half. Okay, everything is taken. Now, let's look at QTP. If I look at QTP, QT is to QP is in the ratio 1:3. TU is to UP is also in the ratio 1:3. This side by this side is 1:3. The base is also getting divided in the ratio 1:3. So that tells me that line QU is an angle bisector. only then you will have 1:3 here and 1:3 here. So this should be an angle bisector. Please type A if the ones who are there in the live session are clear with why that has to be an angle bisector. Because that is angle bisector property. If you have an angle bisector, then the ratio of the left side to the right side will be equal to the ratio of the left part of the base to right part of the base. So as I have got 8:24 as 1:3, I can say this is also 1:3. So this has to be angle bisector. Now look at this. QR is 24, QP is also 24. So these two are equal sides. So I am having an isosceles triangle here from where I am drawing the angle bisector. Intentionally, I have drawn this line like this so that while calculating, I don't end up assuming that this is 90 degrees without establishing that it is 90 degrees. But now we have established it is 90 degrees because in an isosceles triangle, when you draw the angle bisector from the vertex that contains the two equal sides, that will also be perpendicular, that will also be bisecting the bottom and so on. Right? That is the altitude, perpendicular bisector, angle bisector, and so on. So this is going to be 90 and it is also going to split the opposite sides into two equal parts because it's the angle bisector coming from the vertex involving the two sides. So these two are going to be equal. We already saw that PS is equal to 24 by root 2. So now I can say RS is also going to be equal to 24 by root 2. And as this is 90 degrees, we have 90 degree here as well. So now we have a right angle triangle, right? So in the right angle triangle, let me just take it this side so that part is very clear. So we have a right angle triangle like this. Okay, we have a right angle triangle like this, where the measure of sides are, this is 24 by root 2. And this is 24, this is 90 degrees. If this is 24 and this is 24 by root 2, then this also has to be 24 by root 2. You can use Pythagoras theorem to see that, but this is something you should keep in your mind. If there are two special right triangles, the ratio of the sides of which you should have in your memory. So one is our 30, 60, 90 right triangle, where the hypotenuse is going to be the side opposite 90. If that is going to be two parts, side opposite 60 should be the root 3 parts, side opposite 30 should be one part. That is one ratio you should remember. The next right angle triangle is 45, 45, 90 right angle triangle, where the ratio is 1:1 root 2. So the moment I see this 24 is 24 by root 2, immediately it clicks the other one also should be 24 by root 2 because already 1:root 2 ratio I have got. In that case, we are dealing with an isosceles right angled triangle. So each of this should be 45, 45. They're asking find the measure of angle QRP. QRP in degrees, answer should be 45 for this question. The ones who are there in the live session, please give me a response. Type 45 if you're clear with how we solved this one. Okay, now I'm going to try my hand at mass point geometry to solve the same question. Let's see how we can approach this question using mass point geometry. I have discussed the concept of mass point geometry in the concept classes. So in case you haven't gone through that, please go through that. Let's quickly go through this question with mass point geometry approach. I'm going to clear off certain things here. Okay, let this be there. All these things can be there. These things we will try to establish. Very tricky for me to exactly clear that one. Okay, I am going to prove this, but not able to clear exactly that. Okay, now let me just put those lines again. Even this is not proved. This 90 and all also not proved. These are also not proved. Let me just put that lines and complete it, because when I erased one, the other one also. So let me put those lines. We have our triangle going like this. These are all given in the question itself. This did not have nothing to do. These are all things given in the question. Now let's look at mass point geometry. As I have got 16 and 8 here, 16 and 8, so the ratio is 2:1. So I can assign a weight of 2 this side and 1 this side. So a weight of 2 here, a weight of 1 here, and 2 plus 1, I have to put a 3 here. Okay, that's how we deal with mass point geometry. Please go through the concepts I have discussed in case you're not familiar with mass point geometry. So 16 means that side weightage is 2, 8 means this side weightage is 1, and then I can put a 3 here. Okay, now let's look at this line also. This side I have 3, so this side weightage is already 3. This side I have 1, so this side weightage should be 1. Now as I have got weightage 1 and 1 here, I can say these two sides should be equal. As the weightage is 1 and 1, these two should be what? 1:1 ratio, right? So now I can prove that those two should be equal. These two will turn out to be equal. So if these two are equal, then you can say 24 by root 2 is going to be the value here as well. Okay, and if this is 3 and this is 1, then this is going to be 4. These are certain observations you can do immediately. 3 and 1, so this is going to be 4. This is 2 and I have got 4 here, so this is going to be 2. So in fact, this is also getting split in the ratio 1:1, which was not required for the question, but you can do that in case you want to. Okay, and the isosceles property will help you to establish that if these two are equal, then this is the median. The median has to be at 90 degrees. That will take us to this. So that's slightly different approach in terms of mass point geometry, where you can again reach to the same conclusion. Please type MPG if you're clear with how to apply mass point geometry aspects to this question in case you want to approach it using MPG. Great. Let's move to the next question. The next question is up in the quiz and on your screen. Okay. Just give me a minute. Let me quickly repeat this. I think the mic was not picking up. Okay, I'm going to repeat this, guys. I'm going to repeat this. Am I audible now? Okay, sorry, the mic was off, I think. By mistake, I must have pressed. Okay. In the figure given below, C1 and C2 are the two circles and centers. O1 and O2 are the radii and radiate 10 units and 12 units respectively. So we have the two circles and the radius of this one is 10, the other one is 12. The distance between O1 and O2 is 16. So this distance is 16. Kn is perpendicular to the line connecting O1 and O2. So this is perpendicular to line connecting O1 and O2. Square of length of the diagonal is what they're asking. Square of length of the diagonal. We know that both the diagonals are going to be of equal length for a rectangle, so it doesn't matter which diagonal we are speaking about. So a diagonal's square I should take. So that is going to be square of Kn plus square of Nm, because in a rectangle all the internal angles will be 90 degrees. So if I use Pythagoras theorem, I can say Kn square plus Nm square will be square of length of the diagonal. So first let me put down what we are supposed to find out. So we would just stick to finding Kn square plus Nm square. That will give us square of length of the diagonal. Okay, so I've just rewritten our question to be like this. Find Kn square and add that to Nm square. Okay, so let's see how we can go about doing that. So this O1, O2, let me connect that. And it is given that O1, O2, the distance between them is 16 units. So let's put that down. This is going to be 16 units. The whole distance is 16. I'll put it here. O1, O2 is 16. Now what I can do is I can probably draw this line also. That will be useful to us anyway later. So let's draw it right now itself. The line connecting these two. And that line will be perpendicular to this line. That's a property of circle. Okay, the line connecting the two intersecting points will be perpendicular to the line connecting the centers of the circle. Okay, now I can probably take it like this to find out the breadth. Let's say from this point to this point, I'll just put some label there so that we can easily discuss about them. Let's say this point is somewhat labeled. Let's say P. This point is Q. Okay, so let's form a small equation here. O1P plus PQ plus QO2 should be equal to 16. So from here till here plus here till here plus here till here should be equal to 16. Right. And we also know that O1 to P is the radius of C1, which is given as 10. So O1 to P, that is O1P plus PQ. So this plus this I can cancel and just say that is going to be equal to 10. Right? This plus this is going to be equal to 10. So 10 plus QO2 is equal to 16. So I can say that part QO2 should be equal to just 6 units. So from here till here, it's going to be only 6 units. That distance. Okay. Similarly, you can also find out this. So instead of taking O1P plus PQ as 10, I could actually take QO2 plus PQ as 12. So if I take this as 12, then I will get this as 4. If I take these two as 12, then I'll get this as 4. So this is equal to 4. O1P is equal to 4. So that is 4. This is 6. 10 is over. Overall, it is 16. So that tells me PQ is going to be equal to 6 or NM is going to be equal to 6. So we have already got this. This is going to be 36. 6 squared. Okay, I want to have a confirmation till here. Please type 36 if you're there in the live session for me to understand that you have understood how NM square is 36. Awesome. Now we'll have to go ahead and find out Kn. Right? If I find Kn, I can use that here and get the answer for this question. Okay, let's see how we can find Kn. Now Kn, I can take just the half of this, right? And this line will also get bisected. So if I take just from here till here, let's say I'm going to call it H, right? I'm going to call that H. And from here till here, from the center till Q, let's say it is X. Now that's going to enable me to form some equations. Let me get rid of these things, the ones that are not necessary. After this, okay. Now what I can do is I can form an equation involving H in two different ways. Once on the basis of the radius of this one, and once on the basis of the radius of that one. So let's do that. If we can get those two equations, probably we can get rid of some variable and try and get the answer here. Okay. Now let me complete the triangles as well. Okay, so that's one triangle that I want to complete. And there's another triangle that I want to complete. Okay, so now let's form our equations. This is given as 10, this is given as 12. Okay, so 8 squared, I can get that as an expression involving 10 and this 4 and this part. Okay, so let's do that. So 8 squared, I'm just taking this triangle. Let me just put the triangle alone here. I have my H here, which is this, and this is going to be 10. And how do I get this one? This one, I can get it as 12 minus X. That will be O till this point, because from here, sorry, not 12, 10 minus X. From O till Q is going to be 10 minus X. If I put, I will get O till this point. So this is going to be 10 minus X. Okay, that's for the left side triangle. For right side triangle, I can again form something like this. This is going to be 12. This is going to be H. And this part from here till here, I can take it as probably 6 plus S. Let's say, why take 12 minus and all that? I'll take it as 6 plus X. From here till here is 6. This is going to be X. So this is 6 plus X. So now these are the two triangles we are going to deal with. We are going to get an expression for H squared and we are going to equate that. So please type 2 if you're clear with how I got the dimensions for these two triangles, the ones who are there in the live session. Dimensions for these two triangles. The one on the left side and one on the right side. I've just taken them out and written here so it's clear for us. Okay, now let's form the equation involving H squared. So on the basis of this, I can say H squared is equal to 10 squared minus this square. So that is 100 minus 10 minus X whole square. And here I can say H square is equal to 12 square, that is 144 minus 6 plus X whole square. As I've got H square on the left side, I can find out what is the value of X by equating the right hand sides. So let's equate the right hand sides here. Change the color. Okay, let's equate the right hand sides. If we equate the right hand sides, what will I get? I'll get 100 minus 10 minus X whole square. So that's going to be A square plus B square minus 2AB. That's equal to 144 minus A square plus B square plus 2AB. Okay, so now let's see. Now this plus X square and plus X square, which is inside the bracket, which will eventually become minus X square, will get cancelled. So I can get rid of them right now itself. So this plus X square and this plus X square will go off. They will become minus X square when I take the minus inside, but they will get cancelled. Okay, so now what are we left with? We are left with 100 minus 100 minus into minus, that is plus 20x is equal to 144 minus 36 minus 12x. Okay, 100 minus 100, so that will go off. 144 minus 36, this 12 will have to go on the other side. So I will have 32x is equal to 144 minus 36. That is going to be 8 and 108. Just a minute. Sometimes brain will get stuck for simple calculations also. 108. Okay, so x will be equal to 108 by 32. Let's cancel with 4. Yeah. So if we remove 4, this will become what? This will become 8. Fourth table, so it's going to be 27. So 27 by 8. So x is equal to 27 by 8. Once I get x is equal to 27 by 8, I can go and plug it here. Anywhere. First or the second equation. That will give me 8 squared. But from 8 squared, how do I get kn squared? It's like this. H is going to be half of kn because this line will get bisected by this line. So h is going to be half of kn. So if I do 4 times of h squared, I will get kn squared. So the relation between h and kn is like this. Let me put it here. Kn by 2 is equal to h, or I can say kn is equal to h. Kn square is equal to 4h squared. So this I can actually take it as 4 times of h squared. So I'm going to plug this here, 27 by 8 here. That will give me 8 squared. I'll have to do 4 times of h squared and take it here. That should give me the answer for this question. So after this, you can use your calculator here. It will become slightly simpler. So our expression will become this one. I'm going to take down. I'm going to take this one down. So 8 square will become 144 minus 6 plus 27 by 8 whole square. I'm not going to solve this completely. You can put this in your calculator. Let me see if anybody is getting the answer. Put this in your calculator. 144 minus this whole square into 4 plus 36 and tell me what answer you're getting. If the exam doesn't allow you calculator, this is going to take a bit of time. But if it is like CAT where you're allowed calculator, this should not take too much time. The question is asking for closest to which of the following. Okay, so this is coming to 56.1. This expression is coming to 56.1. If you use your calculator, you get 56.1. 8 squared. I'll have to multiply it by 4 here. Right. So 4 times of 56.1 plus 36 should be our answer. So let's do it. 4 times of, let me put it here. 4 times of 56.1 plus 36. So that will be 4, 24, remainder 2, 22, 224 plus 36. So 224 plus 36 is 260, 260.4 we will get here. 260.4, they're asking closest to which of the following, 260 units. Option 2 is the answer for this question. Please type 2 if you're clear, the guys who are there in the live session. Okay, a bit of calculation is required here, but with calculator like CAT, you should not have any problem here. So let me quickly take you through what we did. First, we established the breadth of this, saying no, this part plus this part is 12, this part plus this part. It's basically A plus B plus C is 16, A plus B is 10, B plus C is 12. So what is that B? It's that kind of a situation. Okay, this plus this is 16. Two of them are equal to 10. These two of them are equal to 12. So what is the middle value? We got that as 6. That's the first thing. Next, we formed these two triangles and we try to have only two variables, h and x. You can take this as x or you can take this also as x. One of the sides you can take as x. And form equations involving h. So we got two equations with h squared is equal to something, h squared is equal to something. We equated them, we got a value for x. We substituted the value for this, we got h squared. And then we related h squared to kn square. Kn by 2 is equal to 8. So kn squared is 4 times of h squared. So 4 times of that plus this would give us the answer. Okay, let's move to the next question. Okay, in CAT kind of situation, how long will it take to do this question? See, this question is definitely on the slightly on the tougher side. Okay, it might take you maybe around 3 minutes to solve a question like this, even if you know what kind of logic is involved in the question. Okay, but so you might have a few questions of this kind also, right? Which could be those final questions that you might have to crack to go from 98 to 99 percentile or something like that. Thing is, the logics that we're discussing here will help you to solve multiple questions of even lesser difficulty level. So around 3 minutes, I would say, is the time required to solve a question. Provided the ideas click. If ideas are not clicking, then you might have to take a call at the end of around 1.5 to 2 minutes itself as to whether you're going to attempt this question or leave it and move forward. Is that clear? Did that answer the question? Ideally, how much time we should spend for a question like this? Okay, let's move to the last question for today's discussion, guys. The question is up in the quiz. It is up on your screens as well. Last 30 seconds. Great. The time is up. Let's discuss this one. Let's see what is the status of the leaderboard, the final status of the leaderboard. Rahul Menon is on top, 7.5. Triveni 5.7, Sultan 5.6, and so on. Congrats, guys. Let's go ahead and discuss this one. In the figure given below, ABCD is a rectangle with AB is 80 units and BC is 60 units. So AB is 80 units, BC is 60 units. Let's put that down. AB is 80, BC is 60. Okay, and we are dealing with a rectangle. So I can take Pythagoras theorem and say AC is going to be 100. 3, 4, 5 triplet. Okay, 3 into 20, 4 into 20. So this is 5 into 20. So AC is going to be 100. Let me put it here. AC is going to be 100 units. Okay. A circle is drawn inside the rectangle such that it internally touches the sides AB, BC, and AD at one point each. Okay, it's starting like this. And the smaller circle is drawn touching the side CD and the point of tangency of the bigger circle. And diagonal AC. So what will happen is, as this is touching the point of tangency, I can say the center of this, the point of tangency, and the center of this will be in a straight line. So let's draw that line. Let's put the centers here. This is the center of the circle, center of the circle, and the point of tangency. They should be in a straight line. I'll draw that line now. Okay, we'll have a line like this. Okay, it makes sense to connect that line to the different radius points which are touching the other one. For whatever it is worth, it might be helpful to us. Okay, great. So these are certain things which we can infer immediately. Touching the side CD and a point of tangent of the bigger circle and the diagonal AC. What is the circumference? Sorry, circumference of the smaller circle. Circumference of the smaller circle. Okay, let's say the radius of the larger circle is taken as capital R. Okay, so capital R. Now that capital R is actually in radius of triangle ABC, and that is a right angle triangle where we know hypotenuse is equal to 100. These two are 60 and 80. So I can find out in radius of the right angle triangle right now. Let's do it. In radius of a right angle triangle. Just a minute. Okay, in radius of a right angle triangle can be taken as sum of the perpendicular sides minus hypotenuse by 2. Sum of the perpendicular sides is 80 plus 60, 140. So this is 140 minus 100. We got AC as 100 already. By 2, that is 40 by 2, we will get 20. So this part is 20, this is 20, this is 20, this is 20, all these are 20. Let me put that, let me mark those as 20. So from here till here is going to be 20 units. Here till here is also going to be 20 units. This is 20. Just marking them so that it will click me if there is something that's going to come out of that. Okay. And okay, so let's keep it like that. Now the other thing I can figure out is, as AB is 80, I can say A till this point, from here till this point is going to be 60. That 80 is for the entire length. So A till this point is going to be 60, which means A till this point is also going to be 60. Why? Because A is the external point from where these two tangents are being drawn. Right? These two tangents are being drawn to the circle from the external point. So from here till here, if it is 60, from here till here also it is going to be 60. We know AC is equal to 100. So from here till C, from this point of tangent C till C is going to be 40. So from here till point of tangency is 40 means from here till this point is also going to be 40. These are certain things that I can immediately put down. I don't know where they are going to help me right now, but these are things that I don't want to miss noticing. So I'm putting them down right away. Okay, now what can we do? Let's look at this. I can put a small r. That's what we are trying to find out. Not this r. This r is already done. That's equal to 20. This small r is for the radius of the small circle. This is the incircle r, which we already found as 20. I'll just get rid of this. We have already got that value here in circle radius. Okay. Now I can probably try and complete a right angle triangle here. From there, I can try and figure out what we can do. Okay, so let's complete this right angle triangle because that is going to involve this 20 with r, probably Pythagoras theorem, something I can do. So let's figure out. I'm first going to complete this triangle for whatever it is worth. That might give me some idea as to how I can involve r in an equation. So let's complete this one. Let's say I'm drawing a perpendicular from there and connecting it like this. Okay. Now what will be the dimension of this one? We know from here till here is 40 and from here till here is going to be 20. This 20 will come down here, right? As the whole thing is 40, from here till here is 20. I can say this will be 20. So let's put that down. From here till here, it should be 20 because from this point to C is 40. From this point to C is 20, right? All these are 20. So this should be another 20. Perfect. We are getting close to solving this question because I've got two sides of my right angle triangle. If this side also I can get, I will be able to solve either as a number or in terms of r, because that will give me a equation with one variable. Let's see if I can get in terms of number. I know this is 60, but this is still r, but that's also okay. So if this is r, then this part is r, the whole part is 60. So I can say, not this is not whole part is 60. BC is 60. This part is only 40. Similar to this one, guys. AB is 80. BC is 60. So this part is only 40. Let me just cancel the 60 so it doesn't confuse us. From here till here is 40. B till C is 60. So if this is 40 and this is R, then this expression is going to be 40 minus R. Okay. Now I want to get the clutter out of this. So let me draw the figure here and then see what we have got and whether it's making sense or not. So we have got a right angle triangle where this is going to be 20 plus r. This is going to be 40 minus r and this is going to be 20. Perfect. We are just one step away from getting the answer, at least in terms of r. Then we'll go for circumference, which should not be a big deal. Okay. Is everyone clear with how we arrived at this triangle? Please type T, the ones who are there in the live session. Perfect. So now what we can do is we can use Pythagoras theorem to connect these three. Okay, so let's do that. I'm going to clear off all of this and I'm just going to take this up. So this is not required anymore. Okay, let me just do it this side. Let it be there on the other side. So let's do it this side. So we will have 20 plus r whole square is equal to 40 minus r whole square plus 20 square. Okay, so this can be simplified. Let's do that. 20 plus r whole square. So a square plus b square plus 2ab is equal to a square plus b square minus 2ab. So r square will get cancelled on both sides. That will leave us with 40r and 80r. Let's take this to the other side. Let me get rid of the two 400s. There's a 400 here. There's a 400 here. There's a 400 here. There's a 400 here. We can get rid of that. So 1600 and let's bring it this side. So I'll get 120R is equal to 1600, or R is equal to 1600 by 120. We can get rid of this. So let's again cancel it in fourth table. I will get 40 by 3. So R is 40 by 3. They're asking for circumference of the circle. So I'll have to do 2 pi R. So 2 into 22 by 7 into 40 by 3. Definitely it's not, cannot be determined. All denominators are 21. And let's look at the numerator units digit. So I will get 2 into 2, 4, 4 into 4, 60. There's only one answer with 60 in the last 2 digits. So answer is option 2 for this question. Type 2 if you're clear with how we solved this question. Type R if you want me to repeat how we solved this question. Perfect. With that, we have come to the end of the discussion. Okay, I did the discussion with the leaderboard. I didn't want to do the discussion with leaderboard. So I'm quickly going to repeat this once. In case you did not understand, you can stay back. Else, we are done with the session. The next session will be on day after tomorrow. I'll catch up with you guys in that session. But I'm going to discuss this question once again to make sure the leaderboard is out of the view for this question. In case you did not understand the first time I discussed, you can stay back. Else, please make sure you leave a like and help me to reach more students through this video. Okay, I'm going to discuss this once again to get the leaderboard out and have a clearer discussion. So let's look at this quickly. I'm going to take you through this time. Okay, AB is 80, so this part is going to be 80. AB is going to be 80. So this is 80. BC is going to be 60. As AB is 80 and BC is 60, and we are dealing with a right angle triangle, so this is going to be 100. So AC is going to be 100. 3, 4, 5 triplet of Pythagoras theorem. Pythagorean triplet 3, 4, 5. So this is 3 into 3 into 20, 4 into 20, 5 into 20. So AC is 100. And the radius of this circle is basically the in circle for ABC. So I can find out in circle here. So in radius is sum of the two perpendicular sides minus hypotenuse by 2. That is 80 plus 60 minus 100 by 2. I'm getting it as 20. The radius of this is 20. Let's quickly put that. If I take this as the center, I can say this is 20, this is 20, this is also 20. Each of that is going to be 20. 20, 20, 20, 20, 20. And as this is 20, I can immediately write from here till here, it's going to be 40. From this point to this point is going to be 40. As this is 20, from here till here, it's going to be 60. As A till this point is 60, A till here will also be 60 because A is the external point from where these two tangents are drawn. Those two tangents will be of equal length. So if from here till here, if it is 60, this is also going to be 60. From here till here, if it is 40, this is also going to be 40. Because A till C, you can take it like A till C is 100, hence this is 40. Or you can also take this as the external point from where these two tangents are drawn. This is also an external point from where these two tangents are drawn. So this is also going to be 40. This is 40, this is 40, this is 40. Perfect. Now they have also given that a circle is drawn inside rectangle such that internally touching. And a smaller circle is drawn touching the side CD and point of tangency of the bigger circle. So this is touching the point of tangency. So point of tangency at that point, it is going to be perpendicular. I mean, this line is going to be perpendicular for this line as well as the radius of the smaller circle. So we can conclude that the center of the smaller circle, this point and the center of the bigger circle, they are going to be on the same line. Okay, so let's draw that line as well. Now I can probably draw this, and these two are going to be small r. Small r, small r. Okay, now I can complete this triangle to involve this r in an equation. So let's complete the triangle. So it would be something like this. Okay, now what will be this? As I know, this is going to be r, and from here till here it is 40. So this part is going to be 40 minus r. That this is going to be from here till here, it's going to be 40 minus r. The reason is from here till here it is 40, from here till here it is r. So this is 40 minus r. Okay, and from here till here it is 40. This part is 20. So this part should be 40 minus 20. This is 20. Now this triangle that I've got here, I'm going to take it separately outside here to get a better view of what I'm going to relate. For a triangle like this, where this is 20 plus r, this is 40 minus r, and this is 20. I can use Pythagoras theorem to relate them. So let's do that. That will give us an equation with only r as a variable. We should be able to find the answer. So 20 plus r whole square is 40 minus r whole square plus 20 square. I'm not going to do it step by step. If you solve this, you will get r value as 40 by 3. Just simplify this. There's no difficulty here. Just simplify this. You'll get r value as 40 by 3. What is the question asking? Circumference of the circle. That's going to be 2 into 22 by 7 into r, which is 40 by 3. Now, if I quickly look at the options, cannot be determined is definitely not the answer. All the others have 21 in the denominator, so there's no way eliminating any of the options on the basis of that. But I can look at the unit digits here. 2 into 2 is 4, 4 into 4 is 6. So I will have a 0 preceded by a 6. And I have only one such option, so answer is option 2 for this question. Great. So happy Diwali, guys. I'll catch up with you guys again in the session next week.